So to factor trinomials, so that's going to be polynomials that have three terms, we can use a guess and check approach. So each of the three trinomials in example 1 have this form. And what you can do is look at the values that appear here and here to make guesses as to how to factor this expression. Let's look at this first one, this x squared plus 5x plus 6. So I'm claiming we can break this apart into a product of two pieces. And if this is going to work, it's got to be x and then a plus sign in both parts. And we're left deciding, well, what numbers can I put here and here so that if I multiply this out, it takes me back to a 5x and a plus 6. What we can do is look at 6 and think about numbers that multiply to 6 yet add to 5. So I'll do that off to the side. So I'm looking at 6. Well, you could have a 1 and a 6, or a 2 and a 3, and I think those are all of my options. So clearly I'm not going to use 1 and 6 because that adds to 7, but if I look here, 2 and 3 add to 5. So let's try that out. I'm going to put a 2 here and a 3 here. I'm just going to see if my answer is correct by multiplying this out. So if I distribute the x to the x, I do in fact get an x squared. If I multiply x to this 3, I get 3x. If I then multiply this 2 to this x, I get 2x. And then if I multiply this 2 to this 3, I get 6. If I combine all the like terms, I get x squared plus 5x plus 6. And what do you know? My answer is in fact correct. So this is going to be our strategy. What we'll do is look at the last number and break it up into numbers that multiply back to it, but then choose the one that adds to this middle term. Let's try this again with x squared minus 6x plus 8. I'm claiming we can break it up into two pieces, but off to the side I'm going to take 8, and I'm going to think about numbers that multiply to 8 yet add to negative 6. Now here this is a little bit different because I have an x and an x. This time both of the numbers have to be negative, and the reason is a negative times a negative is a positive, yet when you add those negative numbers together it would take you back to a negative, hopefully 6. So let's see, for 8 it could be, well, 1 and 8, it can be 2 and 4, and that is it. And technically all those are negative. So it's really negative 1 times negative 8, negative 2 times negative 4. And again, I see that it is our second choice. Negative 2 times negative 4 is positive 8, yet the sum of those two numbers is in fact negative 6. So I'll put this as negative 2 and negative 4. We can go through and check our work, but I know it's going to work out fine. This negative 2 times negative 4 is a positive 8. Yet when I get my middle terms, I'll have a negative 2x, a negative 4x, and that adds to negative 6. Okay, last one. Here I have x squared plus x minus 56. Can we factor this one apart into two pieces? This is really the last case to consider where it's got to be x and x, but this time one's going to be positive and one's going to be negative. This is the only way you could end up with a negative number at the end, if one is positive and one is negative. So I'm looking at really negative 56. Okay, we can list out all the factors, unless you can just think of some that come to mind. Okay, I want it to add to a positive 1. So 8 and 7 multiply to 56. I'll put 7 and 8. And one of those has got to be positive and one has got to be negative. I'm going to put the negative with the 7, and the reason for that is negative 7 times positive 8 is a negative 56, yet the sum of those two is a positive 1, so I'll put 8 here and 7 here. If I multiply this out, I definitely get a negative 56, and my middle terms of 8x and negative 7x add to a positive 1. So this would be the answer for this last piece here. So the last example wasn't too difficult just because the number that appeared in front of the x squared was just a 1, and guessing the answer in that case can often be pretty easy. Things change a little bit though when it's no longer a 1 but it's a 2 or a 3 or some other integer. So the reason is it just increases the number of things that you would have to guess. However, there is the strategy that I have written up here that can help us a little bit. So what we're going to do is introduce a number. We're not just going to look at the last number and think about its factors, but we're going to take the product of the first and the last number together. So that's 2 times 4, which is 8. So it's not just the last number, but the product of these two. I'm now going to take factors of 8 and choose one that adds to 9. So for 8, you could have 1 and 8, you could have 2 and 4. Okay, clearly this is going to be the first option. 1 plus 8 is 9. That matches up with the middle term. So here is the strategy. It's going to look a little bit different, but we're going to use factor by grouping to get our answer. What we're going to do is take 9x and we're going to break it apart into a 1x and an 8x. We're going to introduce 4 terms into this expression. That is, we have 2x squared, but I'm going to put plus x plus 8x plus 4. So all I did was I took this 9x and I looked over here and said I'm going to break it apart as a 1x and an 8x. This line and this line are equivalent. Now what I'm going to do is look at the first 2 terms and the last 2 terms and remove the greatest common factor from both of those. All right, so for the first 2 terms, the greatest common factor is x. And for the last 2 terms, the greatest common factor is 4. Here's my next line. If I take out an x, I'm left with 2x plus 1. And in the last 2 terms, if I take out a 4, I'm left with also 2x plus 1. Okay, this is great. I get 2x plus 1 and 2x plus 1, which I can now remove from both of those terms. I take out the 2x plus 1, and I'm left with x and 4. And this is the final answer. So just to recap, we started with a trinomial. I wasn't sure of how to guess the factors, so I took the product of the first and the last number, which was 8, and I chose factors that added to the middle term. When I did that, I broke this up into 2 pieces and used a factor by grouping approach to get my answer. This will always work. If you choose this correctly, you'll always end up with 2 pieces that can be removed because they're the same. So this is definitely a complicated idea, but let's try it in one more example, maybe one that's just a little bit more complicated. So I have 6x cubed minus 7x squared minus 5x. And the issue here is this one doesn't even end in a number. It's 5x, not just like 5. But what we can do as a first initial step is, I'm noticing that there's a greatest common factor of x from these 3 terms. So my first step is actually going to be to remove the greatest common factor of x. If I do that, I have x times 6x squared minus 7x minus 5. You can check. If you multiply the x back in, it would take us back to this term. What I can now do is break this thing apart, just the stuff inside the parentheses, by using the method in the previous example, where I'm going to take the 6, the negative 5, multiply them together, and then choose the factors that would add to give me this negative 7. So let's do that. So I'm taking 6, negative 5, and that gives me negative 30. I now want to choose 2 factors of negative 30 that add to negative 7. Okay, so there's a lot of options, but I think I'm going to use 3 and 10, and I just want to choose the negative to be on the correct number. And I think I'm going to put it with the 10. 3 times negative 10 is definitely negative 30, yet the sum of those 2 numbers is negative 7. Perfect, this is it. I'm going to copy this whole line down again, but I'm going to rewrite negative 7x as 3x minus 10x. Let's write that out. I get x. I'm leaving that alone. I have 6x squared plus 3x minus 10x minus 5. So all I did was split this thing apart using those two numbers. I'm now going to remove the greatest common factor from the first two and last two terms. For the first two terms, the greatest common factor is 3x. And for the last two terms, I think I'm going to actually take out the negative. That seemed to work out nicely in the previous lesson. So you don't always have to do this, but I'll take out the negative, and I think I can remove a 5 as well. If I do this, again, I'm copying down that x, nothing special there. But for the first two terms, I take out the 3x, and I have 2x plus 1 left over. If I take out that negative 5 from the last two terms, I get 2x plus 1 left over as well. Within the parentheses, I now have a 2x plus 1 and another 2x plus 1. This and this are identical. I can remove it from both terms. So I have x, parentheses, I take out the 2x plus 1, and then what is left over is 3x minus 5. I have this set of parentheses, which is a little bit redundant at this point, so I'm going to get rid of those and write my answer as x times 2x plus 1 times 3x minus 5. And that is it.